Okay, I got a question in the homework document about this problem from the stereoisomer practice. So we're looking at cis and also the E isomer. All right, we learned during HL time that for both cis trans and EZ, these are both examples of stereoisomers, meaning they somehow differ in their 3D shape. By the way, enantiomers and diastereomers are also stereoisomers, as are conformational isomers. But here we're looking at the cis-trans EZ, and both of these we saw in relation with double bonds. So cis-trans and EZ isomers we get when we have double bonds. All right, so why do we have two different names for isomers that happen with double bonds? Well, cis and trans, you can only use cis and trans to describe really particular situations. When I have, for example, the same substituent on both sides, or excuse me, on the same side of the double bond, we refer to that as cis. If I were to have CH3, excuse me, I should really write this in the correct order. H3C, CH3. If I had the same substituent on opposite sides of the double bond, well, that would be an example of trans. So cis and trans really only happen when we have two of the same substituent. We've had a few questions of, does it have to be the same exact substituent or could it be a similar substituent? Which is a really good question. I think ultimately what it comes down to is that cis and trans is just not as specific as EZ isomers. So for example, if I had something like this, bromine and chlorine, well, to me this is also I would also use the word trans to describe this because I have my same functional group, my halogen alkane, on opposite sides of the double bond. The only other thing that I have here is hydrogen. Hydrogen, of course, I have two of the same. I have hydrogen, so this would be an example of trans, but kind of weird, not exactly the same substituent. So cis-trans only happens when I clearly have the same or really similar things going on across my double bond. So let's take a look at my isomers here. So I see I have two of the same exact substituents on the same side of this double bond. So A, I would refer to as cis. B, I have two of the same exact substituents on the same side of the double bond, cis. C is a little weird, but yeah, I have two of the same exact isomers on opposite sides of the double bond. Br and Br, CH3 and CH3 are on opposite sides, so I'd call that trans. And then D, again, we have the same substituent on the same side of the double bond, so cis. There are plenty of molecules with a double bond where you just can't say cis or trans. It just doesn't work to describe them. And so that's why we have E and Z. How do I figure out EZ priority? For EZ priority, I look at each carbon individually and figure out the priority based on atomic number. So what does that look like with A? Well, I'm going to look at this first carbon and I compare Br and CH3. Br has a higher priority than CH3. I look at my second carbon and I see H and CH3, while carbon has a higher atomic number than hydrogen. So my higher priority groups, according to EZ isomerism, are on opposite sides of the double bond. So I actually have E. In B, well, I look at my first carbon, I look at Br and hydrogen. Br is a higher atomic number than hydrogen. I look at my second carbon, again, I have Br and hydrogen. Br has a higher atomic number than hydrogen, so my higher priority group's on the same side I remember this same, same, kind of pretend that same rhymes with a Z. I don't know. That works for me. This is Z. So we see that cis and E and cis or cis and Z, that cis trans and EZ don't necessarily line up. By which I mean to say if I have cis, that does not always mean that I have E or always mean that I have Z. You need to figure these out separately. So A is cis and E, B is cis and Z, C, this first carbon, Br and Br, these are exactly equal. So I can't assign priority. The second carbon, these are also exactly equal. So I can't use EZ to describe this molecule. The only thing that I could use would be the trans. Okay. And D, well, I have the methyl groups on the same side. I also have my higher priorities in the CH3s, and so this would be another example of cis and Z. So the only example of cis and E I have is A. All right, let me know what questions you have about this. I'm sensing that there's still some confusion and some questions over cis, trans, EZ. I encourage you to go back to the notes, go back to what we did during HL time, and then keep asking questions in the homework document. All right, good luck.